Welcome. Today, I have an amazing guest, and her name is Dr. Lisa Mosconi. She's a neuroscientist and a researcher on the extraordinary relationships between the brain and food. She's both extremely well-versed in the brain and how it works, so hear about her background of research in Alzheimer's and other work, and she also has a degree in nutrition. And so her particular area of expertise is understanding the intersection between the two. So today, Lisa's going to tell us all about our brain on food, what to eat, what to avoid, and how to supercharge our mental spaces. Welcome, Lisa.
Hi, thank you so much for having me.
My absolute pleasure. Can you start by giving us a little bit of background on yourself and how you got into this work?
Sure. So like you said, I am a neuroscientist, and my background is really that both of my parents are nuclear physicists, like both of them, which is why it's quite a thing. Growing up that way was very interesting. And my mom used to teach nuclear physics to students who then transferred to medicine, and they went to work in nuclear medicine. So I was immediately drawn towards that field, which is really code for brain imaging. And from a very, very early age, I really wanted to study the brain. I'm a little bit of a nerd, like very openly self-declared nerd. And I was really, really interested in the brain. And that's in part because my grandmother developed Alzheimer's disease, was diagnosed with Alzheimer's disease when she was in her 80s. And then her two sisters also developed the same condition, and their brother did not, which was quite like, oh, so in my family, it really attacks women's brain, right, more than men's brains. And my mom is super healthy. She's doing all the things I'm telling her to do. You know, she's not touching sugar. She's doing yoga. She's really big on yoga and meditation and super healthy. But so I really wanted to have answers and come up with solutions. So I did a dual PhD in neuroscience and nuclear medicine. And then I transferred so I'm from Florence in Italy. I should have said that.
Hence the beautiful accent.
Oh, that's actually bizarre. It's a combination of Italian and French, because actually French is my second language. So I know my accent is a little weird.
It's gorgeous.
Thank you. So I was studying in Florence, and then I transferred to NYU Medical College in NYU School of Medicine, actually, in New York City. And I finished my PhD here, and I was really looking at genetics. Like, I thought that your DNA was the cause of every evil, of all evil. And I really wanted to find out what kind of genetic factors were running in families and how brain conditions are transmitted to a person to the other. And then it turned out that the role of genetics is not nearly as predominant as we thought it was, as we thought it would be. And especially for brain diseases like Alzheimer's, really genetic mutations account for about 1% of the entire population. So it's really not nearly as predominant as we previously thought, which really led me to look at lifestyle and environment and everything else that is in our control and how that really impacts the brain. So that's the story.
And what kind of training did you then get in nutrition? How did the nutrition aspect come in?
Yes, so right after my PhD, I was hired at NYU School of Medicine as an assistant professor in psychiatry, in this case. And I realized that none of us was actually prepared to give any advice about nutrition or diet or physical exercise, for what matters. And so I went back to school, and I am now a board certified integrative nutritionist and holistic healthcare practitioner from the Institute for Integrative Nutrition in New York and also SUNY, State University of New York.
Just in case.
Just in case, yes.
Just in case 2 PhDs was not sufficient.
Yeah. And then I started my own lab at NYU. It was the Nutrition and Brain Fitness Lab, which is a very literal name. Scientists are very like nutrition and brain fitness, right? Nothing fancy or fashionable, just to the point. And then just recently in 2016, I moved to Weill Cornell Medical College in New York City because they started the first Alzheimer's prevention clinic in the United States a few years ago. And I am now associate director of the clinic. And also, we just launched the Women's Brain Initiative, the Weill Cornell. So I'm the director of the Women's Brain Initiative. And the reason I've been doing that is that Alzheimer's disease actually affects more women than men. So for every 3 Alzheimer's patients, 2 are women, pretty much all over the world. And this has been overlooked for decades. And only recently, in part because of my work and colleagues' work, we really came to the understanding that women's brains are not the same as men's brains.
So I have to ask, in what ways are women's brains different?
In many, many ways. And it's literally not, no, I'm not talking about behaviors or ideas. It's not some kind of psychological finding where women are more emotional and men are more practical. Nothing like that. It's really the raw biology of the brain that is different. We're wired a little bit differently because women's brains are really driven by a specific kind of hormone called estrogen, right? The main female hormone. And hormones have a huge role in the health of our brains, the role that has been really neglected in neurology and neuroscience forever, pretty much. Until the 1960s, people didn't even believe the hormones had anything to do with behavior. They really thought that hormones were just things that would make you fertile or not fertile and would make you more sexually driven or less. So everything was like hormones equals sex, right? And just recently, we've actually come to understand that hormones play a huge role in brain health, especially in women's brains, because we're so estrogen dependent. And estrogen is not just a hormone that makes you fertile, but actually it's a very energizing hormone. So it has a lot of effects in the brain, including really increasing brain energy levels, and is also part of the immune system. So it works with the immune system to really make our brain strong and resilient. So what happens as we get older and we lose our estrogens and we go through menopause is that our brains start aging much faster. And that could potentially lead to an earlier onset of conditions like Alzheimer's disease in women's brains. Depression in midlife is very common. There are a lot of conditions that really become more prevalent in women after or during the years leading up to menopause. So this is what we're trying to understand. Obviously, we're trying to understand, what do we do about that? How do we stop it? How do we change it?
So through your studies in nutrition, you discovered that is really a lot that we can do to support our brain health by eating effectively. Can you start with just giving us your top recommendation for how or what to eat?
Yes. So I would start by saying that as a society, we're very much aware that the foods we eat change our bodies and the way we look. But we're much less aware that the foods we eat also change our brain. So they change not just the way we look, but also the way we think. That, for me, was a very powerful message that I really completely overlooked as a scientist until very recently, because in school, we just don't study diet or nutrition. And for me, it was like, so all these chemicals that I'm studying in the brain, magnesium, potassium, fatty acids, protein, tryptophan, where are they actually coming from? And it never occurred to me they were coming from the diet. And so when I finally got it, then neurochemistry can really explain what kind of nutrients are good for the brain. Because what happens is that the brain is very selective in the kind of nutrients that can get inside the brain even. So the brain comes with a blood-brain barrier, and the blood-brain barrier has very specific gates that the brain itself opens and closes when it wants food. So it's really the brain that says, oh, I'm low on glucose, let me open the glucose gate so that the glucose can get in. They're called glucose receptors, and there are receptors for protein, there are channels for vitamins and minerals, but not for all of these nutrients. So only very selective nutrients can get inside the brain. And that tells you what kind of foods also the brain wants, because foods provide the nutrients. definitely. It was very fascinating for me
Yeah, so you can
when I
do
got there.
a work back on what the brain needs. The
Yes,
things that it's made out of are the things that it's going to require.
yes, in part, in part. That's actually not true for fat, believe it or not. See, when we think about the brain, it's very common to say, well, the brain is made of fat, so we really need a lot of fat. I need to eat a lot of fat in the diet to replenish the fat inside my brain.
Yeah, that's a
And
very common thing that you hear. I've even had doctors tell me that, literally.
yeah, and that's really actually not entirely true. I mean, in part it is correct because so the brain is made mostly of cholesterol,
Hmm.
saturated fat, and polyunsaturated fatty acid, right? Like omega-6 and omega-3. So cholesterol from the diet just can't get inside the brain. There are no gates for cholesterol to ever get inside the brain. So all the cholesterol in the brain is made by the brain itself when we're born. And then it's completely sealed off from the rest of the body, and no cholesterol will ever get in, and very little gets out. Saturated fat, like the type of fat that you get a lot of in meat or dairy, but also in coconut oil or other saturated vegetable oil, can get inside the brain when we're children and all the way throughout adolescence. But then uptake in brain decreases tremendously. And throughout our adult lifespan, only just a tiny little bit goes inside the brain. So the only kind of fat that the brain needs and wants like daily is polyunsaturated, like omega-3 fatty acid and omega-6 fatty acid. And those are the main fat that we really need to provide to our bodies and brain on a daily basis.
So it's amazing. So our brain, I heard a stat, it's supposed to be our brains are made up of 50% fat, but in your book, you talk about the fact that the brain's probably only about 11% fat. And actually,
Yeah, it depends on how you think about it. I find, so as a scientist, I'm very interested in a brain that is alive, right? It's functioning, is there inside your head. And that's called total brain volume. And total brain volume is really mostly water. So 80% is water, 11% is fat, 8% I think is protein, and there's like just a handful of vitamins and minerals and glucose. If you take the brain out of a person and take all the water out, then you have a dry mass. Then the proportion of the nutrients obviously shift because you get rid of water and then about 50% is fat and 46% is protein and the rest is sugar, vitamins, and minerals. And a real brain is mostly water. And the key message there is that we have to replenish this water constantly because the body doesn't produce it on its own. And the brain is so, it's literally built on water. Every chemical reaction that takes place inside the brain needs water to occur, right? All the time when you see, as a neuroscientist, when you see like ATP is coming out, and that's because acetyl coenzyme A was turned into using H2O. So water is really everywhere, and even energy production is based on water. You can't have energy inside your brain unless you have water. And the reason I'm saying that is that even mild dehydration can severely affect the brain and cause neurological symptoms. So even just a 2% water loss in the brain can cause neurological symptoms like fatigue, dizziness, confusion, brain fog, and some brain imaging studies show that if you are dehydrated, your brain literally shrinks, and you don't want your brain to shrink, right? Don't want that.
so going to the prescription, then, how much water should we be drinking every day to avoid any amount of dehydration?
So the average person loses about the equivalent of 8 glasses of water per day, just through perspiration, urination, just regular physiological functions. So those famous 8 glasses a day is a good rule of thumb, just to say that's the minimum that your body really needs just to maintain fluids all the time. And then it depends if you live in a very warm climate, which you and I do not.
Sadly,
Really gone sadly.
unfortunately.
No, but people who do need obviously to drink more water. If you're very physically active, you need more water. If you're taking medications, you need more water just to metabolize them faster. If you're aging, you need more water, because what happens in older individuals is that the feeling of thirst, like the sensation of thirst, is actually suppressed in the brain as we get older. Yes, and so many people who are over 60 don't report feeling thirsty even when they're dehydrated, just kind of lose insight on their own thirst level. So it's really important to keep hydrated. And what I want to underline is that not all water is equal, right? And the brain doesn't just need something wet. So if you drink milk, it's not the same as drinking water. If you need soda, it's not the same as drinking water. If you're drinking coffee, it's not the same as drinking water. And most importantly, if you drink purified water, that's really not water anymore, because all the electrolytes are gone. So
that's interesting. So
yeah.
Most people who purify their water think that they're doing a service to themselves. How do you recommend people do drink their water?
I think the question is, why do you purify it? So do you live in a place where water is incredibly polluted? Because if you do, then you have to purify it to avoid toxins. So if we're drinking purified water because we're concerned about toxins and impurities in the water and poisoning, then it's helpful to drink something else that is rehydrating. And that could be taking rehydration salts, could be taking a mineral supplement, could be buying spring water instead of buying purified water. That actually would be the best thing. Even things like coconut water is very rehydrating. Aloe juice is very rehydrating.
So what do you consider to be toxic water? So you live in New York City. Do you drink New York City tap water?
We actually have filters. We have a fancy under the sink filter that removes any trace of like heavy metals, for instance, but preserves the electrolytes in the water. And I am told that the water in New York is actually really good. And for me, when I moved from Italy and I tried drinking tap water, I was like, oh dear, what is this? So I got used to it, but I actually buy drink water. I treat myself to actual good water.
New York City tap water is actually some of the better tap water in the United States.
I heard. I was in Boston just recently, and I can't drink it. I'm from the tap. I was like, no, this is just not. I was just to my daughter, just do not drink it. We're gonna go buy something better. No, really, water is just so important. You need it. You need the electrolytes, and you need to keep your brain hydrated. Like there were studies, like many studies, showing that. So, like in a clinical trial type thing, like an experiment, where a lot of people who were about to do a test measuring reaction times and processing speed, and some of them were given like an energy bar before the test, but no water. Some were giving an energy bar and water, and some were given only water. And people who were drinking water performed just so much better than those who got no water whatsoever for hours prior to the test. So literally just drinking a glass of water 30 minutes prior to a test improved reaction times by like over 30%.
That's amazing.
Yes. And it's so simple. And so many Americans are really dehydrated. There was a report from the Centers for Disease Control and Prevention showing that at least 10% of Americans report drinking zero water on a daily basis. Like none. Yeah.
We think distracted driving is an issue. Slow reaction times due to dehydration.
There you go. There you go. You never know.
So if you do have a filter, you referenced taking electrolyte salts. What is your solution if you're drinking filtered water in order to have sufficient electrolytes?
I would say sodium, potassium, glucose. If you're so if you're dehydrated, then you need to take oral rehydration salt. And those are usually sodium and glucose. It's like an oral IV. Like you don't get an actual IV, but you just drink it. And that's for people who are actually severely dehydrated. For everybody else, I would say like the standard electrolyte formula could help. You can just buy them; they're already prepared, like this little sachet, like electrolyte. They really help. They really help.
Okay, I'm gonna go buy some.
Yeah, or actually, even better is coconut water, like something. I would say something natural. Like I'm a big supporter of food versus supplement. I find any supplements that come from a lab have none of the potency of the nutrients that come from foods. So for me, I drink aloe vera juice every morning, and my daughter does too. She's great.
Where do you get your aloe vera juice?
From the health food store, but you can get it on Amazon or Thrive Market.
Is it just the Lily of the Valley aloe vera juice?
Uh-huh.
Okay.
I drink that every morning. I've been doing it for, I think, 15 years. And for me, if I don't drink it for like 1 or 2 days, I really feel it. But like I don't drink coffee, even though I'm Italian. But I drink that in the morning, and I'm fine. I'm alert. And I'm a mom with a little girl. So.
And so what do you suggest for nutrition for kids? So you referenced something interesting, which is we don't need to eat saturated fats into adulthood because we get all the saturated fats we need from birth up till teenagerhood. And we don't need any more cholesterol than our brain makes at birth. So obviously what you'd feed a child might be different than what you'd suggest for an adult.
Yeah.
So what can you tell us about the developing brain and the importance of nutrition and maybe some of the differences in nutrition to support it?
Right. Also, one thing I want to clarify is that even as adults, we do need cholesterol and saturated fats for other parts of our body. It's just the brain that doesn't necessarily use it. So it just reconceptualizing those foods for something else than the brain. Just saying it.
Good clarification.
Thank you. But a lot of people are into really high fat diets. So I want to clarify. I'm not going against that. I'm just saying these fats are not as helpful to your brain as you might think. But so for children, it's different. Children do need saturated fat, especially as their brains are developing and neurons are forming, because the saturated fat and cholesterol really provide the structure of the neuron and astrocytes, where the omega-3, omega-6, the polyunsaturated varieties are more for membrane fluidity. So they really provide plasticity, whereas the stronger fat provides scaffolding. So cholesterol, the brain takes care of that on its own. It just doesn't come from the diet ever. Saturated fat instead is really important. So for my daughter, I make sure that she has access to really good quality animal foods. She loves her cheese. So I make sure that I get good quality cheese. Like I believe in organic food a lot, especially for women, because many chemicals that are found in processed foods are actually xenoestrogens. They act like estrogens in the body, but in a negative way. So they really mess up our estrogens in a way that's been associated with very, very early puberty in girls and with, men boobs, but also with increasing rates of cancers in women, especially breast cancer and estrogen-dependent cancers. So I'm a big believer that safer is better. And so I go organic as much as I can. Obviously, I'm aware that it's more expensive, but I think it's worth it, especially with kids. So I'll buy grass-fed beef when she eats beef, or free-range chicken when I give her chicken or eggs, grass-fed milk, sweet cream butter from the farmer market.
So sounds delicious.
She actually eats super healthy. She eats a lot of fish. We eat a lot of fish here, in part because I'm Italian, and in part because fish is really the best natural source of a very specific type of omega-3 called DHA, which is actually the main brain fat. is the most abundant fat inside the brain that needs to be replenished all the time. And fish is really the only source, pretty much. It's the most abundant source. So if you eat a lot of plant-based foods, you get access to a different kind of omega-3 called ALA, alpha-linoleic acid, that can be converted into DHA, but about 70% is lost in the transition or in the conversion. So vegetarians or vegans or people who don't like fish and don't eat fish really need to up their ALA to make sure that their brain have enough DHA. Going back to my child, she eats a lot of fish.
So let's talk a little bit more about fats, and I'll just sort of give an overview for everybody about fats in the brain so we can kind of have a context to it. So we've been talking about saturated fat, which essentially gets used to become the membranes of cells. So all of your cells have a little package around them, the membrane, and that's where you get the structural fats, saturated fats. If you want to get technical, it's a phospholipid bilayer often that creates the cell. Then both in the membrane and around the axons, around your neurons, you're going to have DHA. And so DHA, as you just said, has to be taken from an external source, and it's often fish. There are two sources of DHA. You can either get it from a vegetable source where you're getting ALA that converts to DHA, but unfortunately it'll big loss, or you can get it directly from the source DHA, which is the fish source.
Do you eat fish?
I love fish.
Oh, good.
I love fish, but I'm now recognizing I do not eat a lot of it, but I take a lot of fish oil supplements. So I try to keep my DHA level somewhere around 2,000 to 4,000 mgs of fish oil per day. I've heard that that's what you should be aiming for, and I take high DHA fish oil. So what was your recommendation for how much fish oil one should be taking daily? How much omega-3?
So it's really based on research. I think if you look at the government, they have different guidelines, but the research on brain scans and brain aging kind of point to the fact that for optimal cognitive performance, also sustained over time, 4 grams a day of omega-3 fatty acids, mostly DHA and EPA, seems to really make a big difference. So there are studies that looked at people over time and followed them for many years and showed that those who consume 4 grams and sometimes even more than that a day of omega-3 fatty acids have 70% lower risk of cognitive deterioration later on in life as compared to people who consume less than 2 grams per day.
Wow.
Yeah.
So somebody who consumes 4 grams of DHA is going to have a 70% less chance of cognitive degradation as they age compared to somebody who takes 2 grams, which you would still think is a significant amount.
Yes. And these are not necessarily supplements. It's really the combined intake from foods and supplements. And, when I read that, I was like, well, 4 grams doesn't seem like a lot. And it's really not. It just takes like a piece of fish, some almonds, maybe some extra virgin olive oil. So it's really about eating healthily throughout the day. It's totally doable, even just by eating right. It's really nothing, it's not difficult at all.
But make sure you do it.
Make sure you do it.
The numbers highly suggest doing that.
People don't do that. Yeah, most people do not do that.
Amazing. Let's talk a little bit more about fat. And I keep coming back to it because there's so many debates as to whether you should eat fat or you shouldn't eat fat. And, do we eat saturated fats or do we avoid saturated fats? And I know you have some interesting thoughts on this.
I hope they're interesting. So I approach any question as a scientist would, like what's the evidence for one thing or the other. And fat is a very important part of the diet. There are 3 macronutrients: fat, carbohydrates, and protein. And somehow in popular science or in the nutritional field, we tend to pick enemies, right? And a few years ago, everybody was vegan and nobody would touch animal foods, therefore really decreasing their fat intake to a minimum. In the word is super strict low-fat diet as well, whereas now everybody's going on very high-fat or ketogenic diet. So I think those are kind of extremes. And the truth is probably somewhere in between, right? That everybody's different and different people metabolize nutrients differently. So for some people, a high-fat diet could be helpful. For some people, it could be a disaster. And it's really about knowing yourself and how your body metabolizes fat that I think is more important. And I was talking to Dr. Perlmutter the other day, the author of Grain Brain, and we clearly have different views on high-fat diets, but in a very respectful way, obviously. And I was telling him my concern for women because of the estrogens that we have, women are just better equipped at burning carbohydrates than fat. Whereas men, because they have more testosterone really burns fat very efficiently. So I was saying to him, I feel like men have an advantage in that department because you just have, your body is just engineered to process fat to your advantage. Whereas women's bodies are engineered to just take the fat and store it rather than burning it. And it's not as easy for everybody to really put it to good use. So I think it's really important to talk about fats in some ways, but also quantity and quality of your fat sources. Like at the clinic, a lot of our patients who come to us and say, oh, I'm doing this keto diet, they're basically eating bacon and cheese the entire diet, right? And that is not necessarily healthy. And then there are other people who are on high-fat diet and they're eating salmon and avocado. And that is much healthier overall.
And you have some research in the book that talks about saturated fats and the impact of consuming saturated fats. Can you talk about that a little bit?
Yes. So the research shows that, at least in the brain aging and cognitive health field, trans-saturated fats and saturated fats are not necessarily the healthiest fat for your brain. And so in large scale, population-based epidemiological observational studies, it was shown that people who consume 13 grams or more of saturated fat every day have twice the risk of cognitive decline as compared to people who eat half of that, so 7 grams or less.
Wow.
Yeah. Now, that, of course, doesn't take into account the source of the saturated fat, right? Does it come from bad quality animal foods? Does it come from vegetable oils? Does that make a difference? We don't know. What we know is that overall, if your diet contains more than 13 grams per day of saturated fat, you have a much higher risk of losing your memory as you get older, or not finding words, or developing cognitive impairment.
And 13 grams, about what does that represent?
It's
Is that
not
a sandwich? Is that 5 slices
like,
of bacon?
Yeah, I think if I remember correctly, it's like six slices of bacon and maybe a piece of cheese. I mean, it's not much. If you're eating high fat, fatty foods like from animal products, then it's really easy to get up to 13 grams of saturated fat a day. I'm trying to remember an avocado, how much saturated fat is inside an avocado. It's quite rich, I think. Although avocados are also rich in monounsaturated fatty acids that are good for the heart, and they even contain some polyunsaturated fat that are good for the heart and the brain. So it's really not. I believe in quantity and quality, and I think everybody agrees that your diet should really include a lot of vegetables and fruit and smaller amount of animal foods. I think that's common sense.
Yeah, the tables are really turning. I was having lunch with a bunch of major biohackers, and this was an amazing lunch. There was Dave Asprey, JJ Virgin, Dr. Mark Hyman, the heavy hitters of what you should be eating. And the rest of us at the table, we just sort of sat back and watched what they were ordering and said, well, we'll take what they're taking. So we went for sushi because Dave's feeling was that rice that is cooled then reduces its glycemic index. So we were allowed to have sushi, and sushi, of course, has lots of raw fish. And everybody's agreement was that you need to eat essentially a base of vegetables and meat on the side. So as much as you'd think that all of these biohackers are pro paleo and, just be consuming meat. Amongst this table, it certainly wasn't the case.
Right.
And from every conversation I've had with somebody who is well versed in nutrition at the cutting edge, the feeling is large volumes of vegetables and everything else is the side.
Yes, fiber, right? Really, I think everybody will say that fiber is so important for you and for your health overall, and fiber comes from plant-based foods. There's no way to avoid that.
So part of why fiber is so awesome is that it helps support your gut. Can we talk a little bit about gut?
Yes, and so this is very interesting. So the same way the hormones are not usually associated with brain health, the same thing used to really happen for other parts of our bodies, like our gut. And for many years, the connection between gut health and brain health was completely ignored in neurology or psychiatry. And now instead, it turns out that the way you eat affects the health of your intestines and your digestion. And that in turn has a huge impact on brain health, especially for mood. So there's quite a strong and consistent connection between your intestinal microbiome, right? The microbiome inside your gut and your mood. So it's been shown that there are good bacteria and bad bacteria. Usually you want to have more of the good ones and fewer of the bad ones. But sometimes, because maybe you're taking antibiotics or you're not eating correctly or you're sick or you have Crohn's disease or any sort of GI disorder that kills the good bacteria, the balance is reversed. And when the bad bacteria take over, they have a really bad effect on the brain because they can kind of hijack the nerve that connects the intestines with the brain, and they're able to travel all the way back up to your brain and really affect the permeability of the blood-brain barrier. So basically, they open this gate, they're forcing some gates open that they shouldn't, and then the bacteria can get inside, and a lot of other toxins and waste products can get inside your brain, producing inflammation. And at the same time, they impact the GABA system, which is the calming, soothing system in the brain. And when that happens, people just feel anxious and moody and really stressed out and upset. So there's a strong effect on mood.
Indeed, it looks like bacteria in your gut actually produce GABA. And so they then influence the nerves to your brain, producing significant calming effects due to GABA in your stomach.
Right. The good ones, right? They calm you down. Yeah. Yeah, it's fascinating. It's fascinating. I find in Western medicine there's a tendency to look at the brain as something that's completely isolated to the rest of you. And everybody's so surprised when your stomach actually creates some changes in your brain. When your heart, we say heart health, a happy heart is a happy brain, or a healthy heart is a happy brain. And everybody's like, no, there's no way. Of course. I mean, the brain is in charge of every other organ, every other part of the body, but the rest of the body reports right back to the brain. And so these connections are constantly active. And if you have inflammation somewhere else, if you have a wound or if another part of you is affected, the brain will know and suffer as well, right?
Yeah, Dr. Jim Doty was one of our guests on an earlier podcast. He's a neurosurgeon who is very focused on the heart. And his point was that the heart has more innervations to the brain than the brain has to the heart.
There you go.
So knowing that gut bacteria is so significant to the functioning of our brain, what would you recommend that we eat?
Oh, yes. So I think for optimal gut health, there are 3 nutrients that are really important, or three food groups: fiber, probiotics, and prebiotics. Okay, so probiotics everybody knows about. Those are the live bacteria that you find in yogurt, that you find in fermented vegetables, and basically they go inside your intestines and just replenish the environment with good live bacteria. The tricky part is that they don't necessarily stay there. Right, so there has to be a favorable environment, like a host environment that is able to really take care of them and to be inviting to them, so that they will stay. And that environment is created by fiber and prebiotics. So prebiotics are oligosaccharides. So they're a very specific kind of carbohydrate that is not digestible. So it doesn't get broken down in the stomach, but it just flows right down to the intestine. And that's specifically food for the good bacteria. And prebiotics come from food that have a sweet aftertaste, but they're not necessarily sweet, like onion, beet, some root veggies. Artichokes are really good.
Asparagus.
Asparagus, thank you. Oats, grains in general are good sources. And then fiber obviously is needed just for proper, appropriate digestion. And so elimination of waste products that really help clean your entire body and also get rid of the bad bacteria or toxins everywhere.
And what are your thoughts on eating yogurt to support your probiotic health?
I think it's a very good idea. It's a very healthy food. It's good for you. It's usually depending on the source of yogurt. They can have also a really good amount of protein and could be very highly digestible. So a lot of people have issues with lactose from milk. They have a hard time digesting dairy. But goat milk yogurt is actually much more easily digestible and contains more protein over fat than yogurt made with cow's milk. So I eat goat milk yogurt when I eat yogurt. I like it. And I give it to my daughter as well.
You have an amazing study in the book that references 25 women who were given a cup of yogurt each day. And can you tell us what happens after this cup of yogurt?
Yes, their brains get better on functional MRI. Right? They found an improvement in mood and alertness that was really visible inside their brain using this technique that measures changes in oxygenation levels in the brain called functional MRI or fMRI. And that was really just a cup of yogurt for weeks, just a matter of weeks, right? Maybe 2-3 weeks or something like that. So it was a very fast improvement.
Yeah, and I remember in the specific study, they were shown images that were distressing, and the women who had eaten yogurt said that they had less distress upon seeing these difficult images than women who hadn't. So they're essentially calmer.
Yeah, the yogurt calms you down. So that's good. Good to know.
So yeah, amazing. A cup of yogurt actually produces functional changes in your brain that can be demonstrated on an fMRI. That's crazy when we think about the impact that food can have.
Yes. Now that is true. That is true. There are many examples of that, and I'm particularly interested in like long-term effect. Like fMRI is really interesting for research purposes. Is not diagnostically useful in some ways because it really depends on the day, on the mood, on what you're doing in the morning, what you're doing in the afternoon, what kind of images they're showing to you. Whereas the kind of methods we use are more permanent in a way. They show the way your brain is on average throughout the day. So they're not activation dependent. It's something more like your actual brain signature. And that's what we look at. And we find very clearly that depending on the diet, the brain literally ages and changes in ways that can be really good and really bad.
Wow.
Yeah.
So can you give us an overview of what a good brain diet looks like as opposed to a bad brain diet?
Yes, for sure. So I have one picture in the book that shows 2 different brain scans. It's at the very beginning, and that was very striking to me. It was actually when I really started looking into diet and brain health. So if you look at, let's say, the Mediterranean diet and the Western diet. So the Mediterranean style diet is considered to be one of the healthiest diets on the planet for the heart, the brain, the pancreas, and it's associated with a low risk of Alzheimer's or cardiovascular disease or diabetes or obesity. Everything works when you're eating like we do in the Mediterranean regions. And so people who follow that kind of diet, which is really high in vegetables and fruit, rich in fish and whole grains and low in animal foods overall, and sweet and refined sugars. Of course, there's no processed food or minimal amounts of processed food. The brains of people who have been following the diet for a while look really young. Like their ventricles are nice and tight. Their brains really fill up the entire skull. There's a lot more brain than fluid. And if you look at specific parts of the brain, like the hippocampus or the internal cortex, which are really important for memory, those are really as big as chubby as they can be. And then if you look at hundreds of people who are following like a Western style diet, so a lot of processed foods and soda, lots of meat and dairy, usually low quality food, not a lot of attention towards quality perhaps, and lots of refined grains. Their brains look so much older. So like if somebody's like 52 and they have this, we publish this all the time, for people who are in their early 50s, those in Mediterranean diet look like really good brains, a healthy looking brains. In the brains of people of exactly the same age, same gender, same educational level, same cardiovascular risk factors, the same even ApoE genotypes, the same genetic risk factors for dementia or for cognitive decline later in life. Their brains look like they're so much older, like 5-10 years older, easily. And we constantly flag there's ventricular enlargement. There is atrophy of the hippocampus. You can see that the fluid is taking over and the brain is getting smaller. And it's really constantly diet that comes up on top as the predictor of these changes, much more than age or gender or education or diabetes, you know. It really has a huge...
Wow. So diet is one of the main predictors as to whether a brain is going to look healthy and plump and young or shriveled and crenated and old.
Yes, in research, yes. In my hands, definitely. Usually is the one factor that always comes up on top. And we look at a number of things. Like I mentioned, age, gender, education, but we also look at intellectual activity and physical activity, like aerobic exercise or lack of aerobic exercise, just moving throughout the day, sleep. We look at diabetes, we look at metabolic syndrome, we look at homocysteine, which is it's a marker for cardiovascular disease. We look at BMI, we look at B vitamins. I mean, we measure so many parameters, and when you just put them all inside a statistical model that tells you which of all these factors is the best at explaining or predicting something in the brain, diet always comes up on top. And that's really accounted for everything else.
Wow. So how should we eat? Give us a prescription. Tell us what to do. Tell us what to eat. How do we keep our brains chubby?
So I think the best way to describe it is that you need foods that really support brain health. And foods that support brain health are very rich in anti-inflammatory foods and antioxidant foods and B vitamins. I would say these are the main criteria. So you need a lot of green leafy vegetables and like spinach. I'm going to say kale, although I don't love it, but kale is a good one. Cabbage of all sorts. Broccoli are always very good for you. Dandelion greens are actually some of my favorite. Have you tried them? They're
a little bitter. It's acquired taste. Yeah.
Which means it's also really good for your microbiome, right? For your bacteria. Bitter food is usually really good for the intestine. And they are very, very rich in antioxidant vitamins and minerals. They're very rich in fiber. So these are really good for you. Then fish, like we said, is really very important. I would say low glycemic fruit is really helpful, like berries. And everybody eats blueberries. But actually, blackberries have a higher antioxidant capacity than blueberries. Gooseberries as well. Mm-hmm. And a specific type of gooseberries called amla. They're Indian.
Oh, yeah, the Indian amla. They're incredibly powerful antioxidants.
Yeah.
AMLA, amla, yeah.
Yes. They have
I can only ever find them canned, like canned in tons of sugar, unfortunately.
I have not found them. I haven't been able to find them.
Go into an Indian market. In New
Yeah,
York,
but
go
they're
into
with sugar.
Kalustians.
Oh, okay.
Yeah, do you know where
No.
Kalustians is? It's around like 29th and Lex, somewhere
Sure.
around there. Yeah.
Okay.
Go and check it out. It's the biggest spice store you've ever seen in your entire life. They have thousands of varieties of every spice. I'm exaggerating, but I'm not exaggerating. It's that nuts. It's like a trip to the spice road.
Lovely. I will totally go. I love that. So one food I want to mention is caviar.
Caviar, yes.
Yeah. So and they say caviar because I'm Italian, but what I mean is actually fish egg. In Italian, it's the same word, whether it's fancy or it's
The
not.
fancy, yes. It's New Year's Eve and we're having beluga caviar,
Beluga
darling.
caviar, exactly.
Or
But
the
not
savruga
that.
if you're not as good, yes.
No, but any fish, like salmon roe, like the eggs from the salmon, that's really the best brain food, I think. And that's just really from a neurochemical perspective, because the nutritional content of caviar is pretty much it really mirrors the nutritional composition of the brain. And it's just so dense with the phospholipids that you mentioned, omega-3 fatty acids, omega-6 fatty acids, and antioxidant vitamins. It contains vitamin A and vitamin C. They're so important because they really slow down cellular aging. And there's even selenium, which is a trace mineral that is so hard to find in regular foods, like Brazilian nuts are really good sources, but caviar also contains it, which is very unusual for animal food. It has obviously iron, all the essential amino acids, and also choline, which is like a B vitamin in its functionality, and the brain needs it to make memories, right? To make acetylcholine. So that's really incredible. And it takes literally 2 teaspoons of caviar to get all the stuff that your brain needs basically for the day.
I'm putting fish eggs on my shopping list now.
Yes, do that. I do it often. They can be expensive. We have a little Russian deli nearby. You can get like a quarter pound for $10. So we're fortunate in that regard, but there are ways. I think there are ways to find fish eggs that is not super expensive. It's actually affordable. It's a treat, once in a while. I wouldn't say eat it every day, but it's just good to know. It's good to know.
So that's what we should eat. Now, what should we not eat?
Processed food. Actually, so whenever I'm asked, like, what should I eat for my brain, I usually say, well, the point is that don't eat processed food. If you don't eat processed food, then pretty much anything else will do, in different amounts. You can think about it or be more careful. But processed food is really the worst kind of food one can eat. It's high in everything that's bad for you, for your heart, for your intestine, for your brain as well. Processed food until maybe a year ago could actually contain trans fat, and that is the worst type of fat one can ingest. There are plenty of studies showing that people who consume just 2 grams of trans fat every day have twice the risk of cognitive loss and a neurodegenerative disease like Alzheimer's as compared to people who eat less than 1 gram a day. And 2 grams is nothing. 2 grams is nothing.
Wow. Okay.
Yeah.
So avoid processed food. Can we talk about processed food a little bit more? Because, a lot of people immediately imagine McDonald's or cookies or the things that are obviously processed food. What are some of the less obvious processed foods that we really encounter every day?
Oh, I think so many. Usually packaged foods all involve some degree of processing. I think what seems consistent is that, so there's like raw food that hasn't been processed at all. And then there's any degree of processing, like even when you take an apple, as you dry it, if you add any preservatives, that's actually a processed food, but is minimally processed as compared to McDonald's, for example. And then you go all the way up to ultra processed foods. And those are anything from candy, like Twinkies. I never seen them, but I'm told that they're.
You're told.
No, I never seen them. But Mars bars or the buns, like the burger buns, or bread that can last for 6 months. But if you go to Dwayne Reed and you buy those things that are like canned soups, canned soup is totally processed food, or the spreads like margarine, or those self spreads like whipped cream cheese, that is processed food. Processed cheese. One thing that I've been fighting for years over is string cheese. All children eat it in the United States. You want a snack? Here, have some mozzarella stick. That is actually processed food and is not cheese. Even though it says cheese, it can't really be processed cheese to a level of processing where only 50% of what's in the stick is actual cheese. Everything else is additives, emulsifiers, gums, preservatives, not in the cheese, but coloring are also actually problematic for health.
Okay.
Yeah, yogurt.
No string cheese.
Yogurt. We were talking about yogurt before, right? There's good quality yogurt that is just literally milk, sometimes cream, and live bacteria. And then there's processed yogurt that looks bubblegum pink, right? Or any kind of bizarre color. There's a lot of sugar and all sorts of additives. So if yogurt contains more than 3 or 4 ingredients, and the ingredients really read like chemicals, that is processed food and it's really not good for you.
So like a Dannon yogurt, even though they promote themselves as being healthy, Dannon Activa, you would say that's a processed food and off the list?
I don't know if all the products contain additives, but if they do, then yes, it's processed food. I mean, maybe they have some varieties of Danone that is actually not adulterated in any way. I haven't found any, so I would say yes, Danone is probably not the best kind of yogurt you can eat.
Okay, so we now know a little bit about what we should eat and shouldn't eat. How did we get this way? In the book, you talk very fascinatingly about the evolution of man and how food allows for the evolution of our brain, and food actually allows us to turn into the sentient, capable Homo sapiens that we currently are. Can you take us through that journey a little bit?
Yes. So the human brain really developed based on genes and the interaction between our genes and the environment. In environment back then, which is really millions to millions of years, where men were broadly very similar to apes, included diet and trying not to get killed. Right? So whatever the environment provided interacted with our DNA to stimulate growth or lack of growth. And all the foods that our ancestors were actively looking for and putting into their bodies really altered the way that brain development took place over literally millions of years. And so we need to think about our early ancestors as very unsophisticated humans, intellectually speaking. Their brains were much smaller. They were not nearly as well connected. Entire parts of the brains, like the neocortex, was not yet formed, was still developing. And so these early humans were actually not as coordinated. They couldn't go hunting. There's no way that they could even build weapons back then. So they would literally feed themselves of things that they could find easily, like plants, bugs, fish that they could catch, or snails. So the diet was very primitive in some ways and very similar to that of apes. And as they got access to better and better food, then they got smarter. And so they learned to find more foods like eggs, because our ancestors most likely lived next to rivers, right, to have access to water all the time. And so you could access fish and animals to live in water very easily. So, of course, the brain developed based on that, which is in part why we need so much omega-3 fatty acids for our brain. They found
That's fascinating. So in essence, it was this feed forward. So we began as these less capable individuals because our brains were less capable. Therefore, we couldn't hunt as effectively. And as we got better and better food sources, it developed our brain, which then allowed us to be more ingenious and smarter and better at capturing better food sources, which then fed our brain.
Yes. So at the beginning, everything was plant-based, right? Because plants can't move. So once you find a good source, that's it. You can just feed yourself for a really long time. And that's why very early humans had enormous teeth and enormous jaws, because they really had to like
masticate,
chew, yes, all day long, basically. And then they progressively got access to nutritionally rich foods like eggs and fish. And as they get bigger and smarter, they also learn to follow predators. And so they most likely had access to the carcass, to whatever the predators would not eat, which is like the bone marrow. So our ancestors learned to literally break bones and eat the marrow inside, which is actually very rich in nutrients that nourish the brain, first and foremost.
So they'd basically steal somebody else's kill, the bones that were left behind, and suck at the marrow.
Yeah, and they could, just break the skull and eat the brain of the animal that was left there. And so that's how they literally get bigger and bigger, and then they eventually learn to hunt. But that happened much later in the history of mankind, and then they learned to cook, and that also allowed to eat more and more food. They were more easily absorbable once cooked. But so really the progression is plant-based first, right? Breast milk, of course. Grains were also part of the menu when they could find them. And then fish and eggs, and then eventually meat, wild meat. And then much later on with agriculture, everything changed, agriculture and farming.
That's amazing. And fish really was this turning point. As you sort of reference in the book, fish was this turning point that really allowed the kind of explosion of our brains. Mm-hmm. We all of a sudden had all this DHA, which you just fascinatedly pointed out is possibly why we need DHA. Because in our evolutionary development, we were eating a lot of fish. That was the external source. So our brain became developed with this source of fish alongside of it, with the presumption that we'd always have the source of fish to create the brain that it was creating.
Yeah.
The brain that was evolving as a result of having this fish. And so we now need fish because that was part of our evolutionary development to exist alongside its consumption. That's fascinating.
I agree. I think evolution is insane. It's incredible. You always learn something new, and it's just not obvious. It's just not obvious.
It's also fascinating, the idea that you started talking about genes and how the environment turns on our genes, or food turns on our genes, and that's part of what influenced our development. And that's something that we now see as we're these, fully formed human beings that we are. We still have a genetic environment, internal genetic environment that is triggered and encouraged and shaped by the food that we eat. A lot of people who listen to this podcast are familiar with epigenetics, the idea that we have a genome, a DNA that determines who we are, but then there's environmental factors that turn on and off genes.
Right.
And food is actually one of those epigenetic factors that's really powerful in modulating what genes are turned on and turned off.
Yes. And that's also, it's incredible. Now then, everybody knows intuitively that the foods you eat change your brain. Everybody's always known that. If you're having a bad mood and you have a piece of chocolate. It's bad, right? If you feel really tired and you drink a cup of coffee, you wake up. Everybody knows that intuitively. And I think it's going to take more and more research to really convince everybody otherwise.
How do you plan to execute that research? What do you think it's going to take to convince people that food is medicine?
I find it has to be well done. It really has to be carefully planned and executed research that everybody can understand as scientists and doctors. And I think that really the turning point is that for many years, nutritional research did not include any information on the brain. So the way the studies were done was observational in nature. The investigators would try to recruit thousands and thousands of people and measure their diet today, and then follow these people for like 20 years until some showed cognitive decline, the others did not show cognitive decline. And then they would go back to the baseline and say, okay, what kind of diet did you have? What kind of nutrients did you eat? What is your diet pattern over time? And how much fat do you eat? And can I use your outcome, cognitive intact, cognitively impaired, to define a diet that's actually supportive of cognitive health? I think everybody can see the problem in that. Diets change. It's very hard when you use questionnaires to measure diet. Nobody knows what they're eating, and they're like, no, I never touch cookies, and that's obviously not true. And I think for us, what we're trying to do is to have brain scans all the time. So patients come into the office today, and we do our dietary questionnaires. We have them do journaling, which is really helpful. We also measure nutrients in plasma and serum to also have an objective measure of what the diet pattern shows. And then we put them in a scanner, and we look at their brains. Is your brain active? Is your brain shrinking? Is your brain showing presence of amyloid plaques, Alzheimer's plaques, or tau proteins, or white matter lesions, or their strokes, or their microbleeds, and how does the evolution of your diet correlate with what we see in your brain over time? And I think the more studies are done that way, the better we'll really understand the optimal brain diet.
Amazing. So can you leave our listeners with any last pieces of advice on how to eat for their brains?
I would say just take care of your brain. It's really in your power, and it takes discipline, it takes determination, but it's totally doable. And the benefits are really for life. I always say, treat your brain like your best friend, and just think, this thing I'm about to eat may or may not become part of the very fabric of my brain. Do I want my brain to look like this? Do I not want my brain to look like that? And I think that really has a big impact.
Wow. So we talk about the fact that we are what we eat. And maybe we need to actually take a moment and think about that literally. We are literally the molecules that we're consuming from this Twinkie. Our brain. I
was thinking about the Twinkie too.
Our lipid our lipid bilayers, our cell membranes are going to be made out of these fats. These fats are going to actually take the place of the fats that are in our cell membranes, because we need to get fat in our cell membrane from somewhere. And do you want to eat this fat or that fat? Do you want it to be avocado, or do you want it to be Twinkie that you're made out of?
Yeah, just really think about food as something that has a function inside your body and your brain. And some foods and nutrients will really optimize your cognitive health for the years to come. And some other foods and nutrients will have the totally opposite effect, setting people on a path towards mental decline and cognitive deterioration. And, when you and I are talking, and I'm sure that your diet is super healthy, you're taking progesterone, intranasal, you're a biohacker. And I think so many people who do podcasts and listen to podcasts are actually really educated already. I think the problem is more for people who do not have access to this information. And if you go, even in New Jersey, you can see immediately you cross the border and people just eat differently. And I think it's really about educating everybody and really trying to spread the message as wide and far as we can that food has a strong impact on health. And we really need to pay more attention as a society.
Thank you, Lisa. Thank you for letting us inside your head.
Ooh, thank you.
And inside your stomach and inside your brain. So that was Dr. Lisa Mosconi, PhD neuroscientist, nutritionist, and author of the amazingly informative book, Brain Food: How to Eat to Improve Your Cognitive Power. So if you're fascinated by the information that she shared today, she shares reams of studies, specific recommendations as to exactly the kinds of foods you should be eating, meal planning, menus, questionnaires to help you eat for your cognitive power. Thank you so much for informing us today, Lisa.
Thank you so much for having me.